Hi everyone, and welcome to the full feature demo of UDiTH, the Universal Digital Twin Hub. But before I go into the technical details, let me give you a quick introduction about what actually UDiTH is. UDiTH is nothing less than opening the gates to new horizons. What does it mean? It's CIExpert's innovative next generation digital twin platform. Why this is important? Because it's not an ecosystem by itself. It's a hub that allows you to integrate into your existing ecosystem without having to replace anything. It works with the ecosystem and the environment you already have. It's technically a product evolution that evolved from Universal Plan Viewer, UPV, to build a smarter, stronger foundation and to allow the system and the ecosystem and the environment to expand into the future. It's aimed at a full lifecycle integration. This means it's thinking ahead. It allows you to connect data really across the entire asset lifecycle and provide it to all stakeholders likewise. It's supported by the advanced apps that allow you to streamline your workflows and manage change with the UDiTH advanced apps like tickets, events, workflows, and similar. And artificial intelligence. So UDiTH is AI ready. It allows you to create tools, integrations, and automations with the help of UDiTH's AI framework. And during today's demo, I will also be showing one of the first examples what can be done by using the AI framework. But what is UDiTH? UDiTH is based on 4 main pillars, but that are not separate from each other, but rely upon each other. One of them is the platform that fits seamlessly into your ecosystem, as I mentioned before, everywhere, anytime. The apps that deliver ready-to-use solutions and not just features. So it's very use case centric. The portal, as your central distribution platform, allows central administration and central access to your data, permission-based, simple, and scalable. And the API and the integration. The Universal API adds nearly endless options and full flexibility to expand to the future as mentioned before. And this allows you, for example, with the apps together to create your own apps or have custom integrations prepared. And again, all of this together integrates seamlessly into the platform and the portal. That's what makes UDiTH an overall unit, but modular by design and open by philosophy. So, what is the aim of UDiTH? It's, as I mentioned, the entire asset lifecycle. So during bidding preparation, design, construction, commissioning, operation, maintenance, and turnarounds, and starting from the beginning, UDiTH provides features and use cases that help you in these separate phases. So UDiTH enhances and speeds up the projects from the start during the bidding and preparation by being able to manage information, to manage, for example, RFPs and RFIs, and so on. During the design phase, the UDiTH Toolkit and Conceptual design raise design quality while at the same time allows for a collaborative design review system and much more. During construction, you can use 4D visualizations of your schedule, but also moving object simulation, progress tracking, and similar by integrating it with your other systems. You can actually, it supports detailed planning, reporting, and tracking during commissioning and markup of commissioning systems. During operations maintenance, you can view live data and maintenance management features throughout the whole operation cycle. And last but not least, allows you for turnarounds to do detailed preparations, execution, and reporting. So all of this together forms a very solid foundation. But let's actually look at the software itself. So let's start with the UDiTH workspace. UDiTH workspace is the front-end component of the end users of UDiTH. And it's kept very close to the UPV interface, which makes transferring to UDiTH easy and also supports the user acceptance in the end. This also means that we have kept all the UPV features that made UPV so valuable and built on top of that. This includes general menus like the viewing, the clipping, volume clipping, IntelliClipping, inverse clipping, but also diverse filters, toggles, colorization, measurement like single measurements, coordinate measurements, chain measurements with a total length, and angles as well as diameter measurements. It also includes the custom attributes feature and the configurable tree, so you can build your own work breakdown structure completely based on attributes. Additionally, for UDiTH, you can switch the theme. So you can go to a dark theme, to a light theme, and various predefined themes like Vienna or Scottsdale. But for the demo, I'll stick with the UDiTH light theme. So other than that, the laser scanning is also included and features high definition meshes from point clouds, allowing you, and this is also a very unique feature that still many of UPV users did not know or use. You can isolate individual objects from the laser scan and make them completely individual, including giving them tags and attributes, which kind of makes remodeling of brownfield plants obsolete. You can build your digital twin completely based on laser scans and still have an intelligent digital twin. Other features also included is basically saving your views, going basically directly to views you want to use more than once, like here, stack 3D, stack the UAV, the drone scan, or having the overlap. But more than that, you can also map images and projections. So in this case, when we're talking about the stack, I can, for example, map a photo completely here and use the slider for the transparency. So I could, in this case, even overlap a drone scan, a 3D model, and a picture taken with a regular camera on site. But does it have to be a regular camera? No. You can also use, for example, thermal images to overlay and to identify issues in your asset. Beyond mapping photos, you can also map layout plans, for example. In this case, a piping plan. So I can completely compare my 3D model to my technical documentation and make sure that everything is correct. Also being able to adapt the height here. So a feature that is helpful throughout all types of phases during the full asset lifecycle. The difference with the default, let's say, views to UPV is that now you can click the button to apply a certain view at startup, making it your default view for the plant when it's opened. And admins can also save this to the model as a default view for all the users opening that model. Additionally, again, animation is possible. So in this case, I'll go 1 day per second. What you see here is a 4D extract from Oracle Primavera P6 of the schedule. So everything that is dark blue is currently under construction, and once it assumes its final color, this means it has been constructed. I can stop at any time, I can jump to any date, And combined with a picture overlay and a fixed camera, for example, I could even overlay a picture over this animation to compare the real status, real progress to the scheduled progress in Primavera, MS Project, or whatever you might be using for scheduling tool. Beyond this type of animation, we still have the regular sketch animations. So in this case, we want to move the crane, see if it fits, and move the green vessel to the black laydown area. I will go double speed in here. And what you see here is not a video recorded from UDiTH, but basically a real-time animation that allows me to move around while the animation is running and observe diverse situations from any angle required to make sure everything is completely as it's supposed to be, no collisions or similar. So this makes UDiTH, again, a fully versatile front end for digital twin. And since it's definitely far more than a viewer, it is called UDiTH Workspace now. But let me go back to the default view. And look at IntelliPID sketching and advanced line styles. So in my model, let me actually go directly to an interconnected PID here and create a PID sketch. So in the sketching feature, and many of you probably have seen this before, in UPV, so we can still do conceptual design sketching and create some redlining directly in the PID. Let me just switch the layer color. So in this case, yes, UPV was able to do this as well, but we have taken this a little bit further. So while we can also add additional line here, let me select it and go to the attributes of this line. So in this case, I can now choose between various styles from normal to dashed. Let me zoom in a little bit. Or flexible hose, and basically having hatched area large, hatched area small, heat tracing, even jacketed pipes. All is possible now with the PID sketching, allowing you for a high level redlining. But more than that, I can also create another sketch. Hold on. Here. And for example, say, okay, in this sketch, I want to remove this portion of my original PID by just hiding it. And let me pick blue as a layer color, and then just add a pipeline connecting these two reducers. Once I close the PID sketch, you see instantly it returns to the original, but now I can activate independently the sketches and make them visible or hide them and go back to the original drawing. This way we can really support multi-layer redlining for various use cases like disassembly, assembly, redlining, as build documentation, and many more. So in this case, for the redlining, let me also add a revision cloud. Wonderful. But beyond the PID sketching, there's also some major changes and improvements to the 3D sketching. And that is the multi-layer sketching capability. So let me, first of all, sort this a little bit in a folder here and say, okay, this is my PID redlining. and just drag and drop them into the folder. So now I will create another folder for 3D sketching. And in the 3D sketching, I will now add another sketch, 3D sketch. And this one will be a very simple one. I will be just placing a slab down here. And let me move it a little bit. Let me align the top layer accordingly. So by clicking on these little spheres, I'm actually changing it's a little bit thin, so let's make it a little thicker. I'm changing the dimensions of our tool here, of our sketch, while with the arrows, arrow handles, I can move my sketches. So in this case, let me again scale it a little bit. Perfect. And now I can close this one, and I'll just call it civil. So while UPV was limited in some ways with the sketching, because you could not really combine multiple sketches, so working in a team with separate trades was very difficult because you had to recreate more or less these sketches to put them together into one. Not so with UDiTH. So as you can see, let me actually place it under 3D sketching and create another sketch now. And this one will be structural. Unfortunately, now I don't see my slab, but I can just visualize it here, click on the eye and make it visible while my sketch is still active here. So I will place a platform, scroll down, add a column, add a row, and then just stretch it out. And whilst I do so, under files, under attributes, I could also go to the actual profiles used. In this case, it's the HEB 300 profile. So let's take HEB 500, and you see instantly how my columns have changed the diameter to match the new setting. So now, after I have my structure here, let me remove these parts and perhaps select everything, use the arrow keys to put it in place and move it up a little bit. I know now it is floating in mid-air. There's a reason why we do this. So let me close my sketch, go back to files, make my sketch visible, and now start re-editing the civil part. So now I can just go ahead and place my box here. In the attributes, I will change the box size to length X, 0.4 meters, length 0.4 meters, which was not really smart for slab 6 for the profile here, but no problem. 0.6 meters, and the length Z will be 0.4 meters. So now I can easily just move these concrete blocks and place them underneath my steel structure here. And then I can just go ahead and duplicate the objects, clone them, move them, align. Okay, undo, align them with each other. Should have used the arrow key, and simply adding them to my structure here. I mean, you get the concept. I don't have to repeat it for all of the columns. Let's actually go to the next step. In the files, now I add another sketch. And this sketch we will be calling equipment. So yes, I could place like a cylinder here to represent a vessel, but instead of doing that, just using primitives like vertical equipment, horizontal equipment, boxes, spheres, I will now go to the catalog, equipment, and pick my vertical vessel here. So this is a parametric object that has been created with 3D Symbol Designer, which in the, let's call it old UPV world, was a separate product, only available in combination with the Smart 3D parametric object creation, parametric symbol creation. This has changed. There is, just for UDiTH, for creating parametric symbols for UDiTH, a 3D Symbol Designer Lite included in the UDiTH package. So, having said this, let me also add a pump somewhere down here. And it seems I turned off my civil. Okay, turn it back on. So why this is important? Because now I can align my pump with the slab and make the pump a little bit smaller. Which makes life just easier working with parametric objects. A little bit thinner and then rotate it. Something like this. I can also set the rotation angles directly under the attributes. So in this case, it will be exactly -90. And you see it's perfectly aligned. And again, let's close a sketch, activate the sketch viewing. Let's rename it to this one to equipment. This one to structural. Okay. Equipment. Hitting enter helps. And now we'll add the last layer, which is a piping layer. So in this case, I'll just draw some type of routing here. And as you see, I'm not really paying much attention to the detail. Why? Because I can easily then pick a handle and move it, and the rest of the pipe will adapt accordingly. So now I can add valve here and maybe rotate the valve. So you see, I can do easily quick concept designs. For example, make the valve green and the elbows maybe in a different shade of gray. Easy to visualize, but again, I can turn it off, on and off as required. So in this case, turn off my piping, turn it back on, and I could also now make multiple routes and compare them to each other in this multi-layer sketching. But having placed all my layers into the 3D sketching folder, I can also turn them on and off all together as one unit consisting of multiple traits. But beyond the multi-layer sketching, I can also do a multicolor sketching. So what does multicolor sketching mean? In this case, let me add another sketch here and go to the catalog, to transportation. Whilst you've seen the single color crane, single color equipment during the animation, during the sketching demo, in this case, let's take this crane from the company Grove and place it. As you can see, this crane consists of multiple colors, but not just having two colors. Let me actually pick a bigger one that might have a couple more. So there is no real limit to the number of colors. If I wanted to and put some effort in it, I could also use, for example, transparent blue for the windows and so on. So I can create as many primitives and objects within my parametric symbol to allow a real as possible representation of my object in sketching. So let me delete this object. Well, actually, no, I can leave it here. And I will just rename my layer to transportation. The overall performance of UDiTH has significantly improved towards UPV, but the actual power of UDiTH comes with the integrations with the API and the UDiTH apps. So the UDiTH apps are actually what makes UDiTH modular by design and open by philosophy. This means it's a flexible app ecosystem that's either custom built or ready to use, delivered out of the box, but either way, tailored to your needs. And it's built completely modular, customizable, and thus future ready. So the pre-built apps we deliver with the UDiTH suite is the UDiTH Toolkit, which is a curated suite of ready-to-use applications out of the box. They embed seamlessly into the interface and help you enhance your workflows and improve the user experience. For example, a ticketing system, a workflow system, and a clash detection and management system. And then there's the custom apps and features. So these are either built by third parties, custom built by CI experts for your requirements, or even built by yourself with based on the app controls framework and the universal API. And they can represent all types of tailored feature sets to your individual projects, organizational needs, or use cases that might not even be there yet, but that you would be facing in the future. And that's the part that makes the system future ready. So all in all, the apps allow customization, integration, a raise in productivity, while at the same time giving you full flexibility. So this being said, let's actually look at the UDiTH Toolkit first. So let me start the UDiTH Toolkit. So, and move it into position. And this is now another feature of UDiTH, by the way. Now I did this manually to define window sizes and everything. In the future, I'll just want to add my window layout here and say default toolkit. And in this case, even if I close the toolkit, even if I change window sizes completely, all I have to do is view or even define it as default by applying it at startup. But as you can see, it will go back to my saved Windows layout. So in the UDiTH Toolkit, first thing I have to do is obviously sign in. A separate window will pop up. In this case, I'm using a single sign-on system that's authenticating me in the background. And as soon as that is finished, I'm logged into the UDiTH Toolkit. So the UDiTH ticketing system allows me to create, now actually let me go into the administration first, allows me to create tickets based on my own self-defined fields. So I can say, okay, I have a field tag type, which is a select box with these items available, or I have a checkbox, or I have just a simple issue description text box. So you can easily add fields just graphically, no need to program anything. So in this case, let's go back to our ticket list and create a ticket. So let me make this a bit smaller. A ticket, for example, to mark these missing flanges here at these two pumps. So in this case, I would select both pumps, maybe with the nozzles here, and say create ticket. Okay. And now the fields that I defined, except for the first four, they are fixed by the system and cannot be changed, but all the other fields you can add as your requirement. In this case, I'll just add pump flanges missing. Severity is high. Tag type would be pump, assigned to, in this case, design, currently responsible engineering, and this is just an option field I added. So yeah, let me just put in option 3. And as soon as I make a change, this ticket is saved. In the activities, you can basically see the changes, but I can also enter a text here like I observed an issue with missing 3D design, and then just send it. And you see it's directly showing my name with a comment. So perfect. I could leave the ticket technically and just scroll down here, and now we see here pump flanges missing. Let me double click it and instantly see I'm back in my ticket. I can also select the components. In this case, I'll select all of them and say select and fit. But I'm not really happy with this because I would also like to add these parts here, so the flanges and the bits of pipe. So all I have to do is select them in the model and say, okay, add model components. If I now select everything, do select and fit, you see instantly it gives me back my selected objects or my listed objects. So even if I'm totally somewhere else in the model, all I have to do is select and fit, and I'll be right at the, well, ticket objects. So in this case, I could also add a screenshot, for example, but also upload files from my local machine, documents or similar, anything I think would be required for this ticket. But beyond that, let me go back to the details. You see, we have the ticket ID 32. In my files tree on the right, now I have also a locked folder named P32. So what is this for? In this case, everything I can do in the files tree, and this means animations, comments, drawings, markups, packages, everything I can create with UDiTH, I can create within the ticket. In this case, I will mark the ticket and create a markup, for example. So let me open the folder, edit my markup, and then encircle this here. Let me close my markup. Let me close my selection. And when I open my markup again, I have the markup directly visible. Now I could also add some sketching. For example, placing some piping here. Maybe pull it down a little bit. And add a flange here at the nozzle. Then make the piping a bit shorter. And then by double clicking here, colorize this red. There we go. Okay. Should have moved it down a little bit. Something like this. And now, with this done, I can just, again, close my sketch. Here we go. Leave my ticket. And you see that the whole folder now disappeared. And it doesn't matter if I reopen it or anybody else from my team that has permission to access the tickets in the system. Once I double click and open the ticket, you see that our markup and our sketch are absolutely in place. What effect does this have? So it doesn't matter if it's design reviews, punch lists, or some RFI, RFP discussions. All in all, you can completely share any type of files from the tree across your whole team, or share information with stakeholders easily, directly through the system. That empowers you basically to improve your workflows, to speed up your processes, but also make it retraceable, since it's not, you can change things, but you cannot delete them. So it's always traceable and give you a certain safety and security about what is being done and in which order. And basically you can also define who initiated what here. Actually track it. So before I continue with this nice little object here called approvals, let me actually go to the workflows settings first. So what are workflows? Workflows are technically a list of actions. In this case, for example, issue observed, description. So let me pull this to full screen. When I click on it, I can basically see, okay, the design review team has observed an issue. Responsible is the design team. Perfect. And the forward step would be step 2. Step 2. So I'm going to click on this. You see, none means no user action required, but I can send a message. And everybody that this message concerns would receive an email from the coding team that a ticket has been created. User action is one thing, and I could execute code. So this is a TypeScript scripting functionality here that once this ticket point or ticket step has been reached, you can automatically execute code. And this code does not only have to trigger anything in UDiTH or in UDiTH related systems. You can trigger actions basically in any external system that has any type of API, webhook, whatever. So this makes the system, the workflow system, highly interactive and flexible. But okay, let's go to step 2. So an issue has been observed. No, issue has to be fixed by the design team. So the forward step would be step 3, backward step 1. But since there is no decision, it's just an activity. This means I just have to say, okay, unconfirm, I fixed the issue. It would go to step 3. Step 3 is checking the fix. In this case, somebody authorized, for example, lead engineer, would have to double check if the issue has really been fixed. And for step 3, we have a decision. This means approve or decline, and it can require a signature. So, I mean, I can decide if I want to have it signed or not. In this case, I do want to do that. So, and that way you can form any type of, even the most complex workflows, because you always have the option to say, okay, it's an automatic action, no user action required, the user needs to confirm, or somebody has to approve or decline the solution. And if declined, you could basically step or jump back to any step. So in this case, it jumps back to step 2. If it's approved, it goes to step 4, ticket closed, and basically that's it. So let's go back to our ticket here, to the pump flanges missing, and now click on approvals. You see the simple workflow that I just showed you is already automatically attached because it's been defined as default. I could also show a flowchart that would give me an overview on the actual workflow and workflow steps and decisions. But in this case, let's say I want to say I fixed this issue. So I'll just add a note, for example, fixed, I guess. And since I also belong to the checking team, in this case, I can either sign here, or since it's been stored, I can pull my signature that's been assigned to my account here from the last time I signed. And now I say only one flange has been fixed, and say disapprove. So now you see it jumps back to step 2, fix issue. So I can again do complete. And in this case, I'll just pull my signature again and say, okay, I approve. And you see how the status changes from yellow to green, ticket closed, and thing resolved. So in the tickets overview, in the ticket list, I can also add columns like my options, started, currently responsible, and so on. And I can completely filter, sort and filter by responsibility here. For example, who's responsible, which tickets are open, and similar. And for maybe a better overview, you can also use the Kanban board that will give you a comprehensive overview over the open and closed tickets here. So beyond that, we can also handle events. This is basically something happening in the background. So the system cannot just send emails. It can also react to incoming emails and trigger according events, workflows, tickets, or similar based on the content of the email. This is completely configurable and adaptable to your requirements. But let's look at the Clash Manager and detection. So in this case, let me actually, hold on, delete this clash check and start from scratch. In this case, I want to add a test, and let me put this side by side again. Add a test, and I'll want to check 1672, a pipeline for clashes. So in this case, okay, I've got my new clash, so I'll pick pipeline. And then S1672. Here we go. And I'll just check it against all, or I could check it against another pipeline or structure or whatever, but I'll just leave it at this. And here I can pick rules to apply. These rules can be easily set up in the settings. I will show that in a second. So piping paths within the same pipeline. So this means a pipeline cannot clash with itself, but I'll leave that unchecked. I can exclude clashes between pipes and weld outlets, sock outlets, and so on. So these are a couple of predefined rules. I'll just leave them as it is. We can activate them later on. So now that we're in the results, let me just run the clash check. And you see it has found 11 clashes. So now I could go either click on them and view them, or more or less just browse through them by using the arrow keys, going from one clash to the other. So in these test settings, I could also set the tolerance, change also the colors of the identified components, and so on. But in this case, let me go to the results, and let me just rerun my clash check. And you see, just by changing the tolerance, without doing anything, it still recognized my 11 clashes, but now it says 8 are new, so this means untreated, and 3 are resolved automatically. So let me go back to the rules and say I want to exclude clashes between pipe and weld outlet, sock outlet, and thread outlet, and okay, welds already excluded. I can go back to the results again and say, okay, update my clash check. So now it's resolved 7 and only 4 are new. So what I can do is just filter here for the new ones and click on them. So in this case, yeah, it's part of the support. Let me just approve this. This one here, I can approve that one as well. In this case, this is definitely a clash. So let me set this on review. And this one here, so we're basically missing a penetration here for the pipe. So in this case, it's also a case for review. And once I delete my filter again, I have full overview over my clashes here. If the clashes get resolved in the meantime, so let's say I did a clash check today and I want to repeat it, or I repeat it tomorrow. So tomorrow, today I have fixed already some of the clashes. So all I have to do is rerun the clash check. So if the clashes are removed, it will be automatically detected as resolved. So it will still look for those clashes, but it will see, okay, it's been resolved, so no action required. So in this case, if I go back to the overview, it will always tell me up to date. If I change the model, for example, if I reprocess the model overnight, then it will actually show red. So I will have to rerun the clash check to make sure that we're working with the latest available data here. And you've seen also the speed of the clash detection is, I would consider impressive, also having worked with different systems in the past. So let's then go to the clash settings, where we have filters and rules that we can basically use. So let me go full screen again. So see, I have conditions for my rules. I can say, okay, it's excluded or automatically approved. And that way you can minimize false positives by saying, okay, I want to completely exclude them, so they will not be part of my result list at all. Or I can automatically approve them, which will make them part of my list, but that directly marked as approved and technically not really relevant, so that we have the full scope of handling and not just recognizing, but also managing and treating clashes. And the major benefit is that with the clashing system, you do not rely on a certain input, since UDiTH supports basically all common 3D formats. You can also federate models from different sources, but still perform reliable clash check and clash management on it. So beyond the UDiTH toolkit, which is predefined apps, yes, you can also create your own apps using the Universal API, but also some third-party companies have developed tools for UDiTH already. One of them being a partner of ours, Assai. Let me just show you some of the solutions they have created. For example, connecting to document management system or document management AI. So in this case, it's very simple. Select an object inside. They still have UPV in here. That was more or less before UDiTH was released. But technically, let's pretend it said UDiTH. So in this case, let me select D240, and in the background, it's searching the document management system for available documents. And basically, once I click on it, it shows me a preview of the document selected. So that way, I can directly access it. And once I click on show or click on the preview in a separate screen, in a tab, basically it would open the document. This doesn't necessarily have to be the Assai document management system. With Viewport, they tap into basically various document management systems. But it's an example how a third-party solution integrates into UDiTH seamlessly without the necessity to deal with completely separate searches and disconnected tools. And that's what we understand by the term breaking down silos. Also, another solution that came from Assai Viewport is a tool called Historian Insight. In this case, Historian Insight is a connector connected to an AvivaPI historian server. Does not have to be AvivaPI. It could be more or less any historian server keeping IoT data. So this is, for example, a use case for owners, operators, and control rooms, for example, to be able to have a graphical overview over the status of my plant. So in this case, and just as an additional information, it's a real Viewport server behind it. The sensors obviously are not real, so we are randomizing, or in one case using the sinus curve to simulate the sensor input, but the Viewport server is a real one. So now I have a drop down here for temperature, pressure, flow level, alarms. All this is not really helpful unless I turn on the colorization. In this case, based on this color scale, from temperature from -20 to 300 degrees Celsius, centigrade, I have a colorization of my 3 objects that actually have a sensor behind them for temperature. And I could go pretty much the same way for all the others, like flow, level, and alarms. So as you can see, for alarms, we not only have the colorization, but we also have the alarms list. So in this case, I can see that D240 actually has a low flow, while E240 have quite a high pressure warning and so on. So there's two ways to do it. I can either click in the model on an object and I will get the flow chart like here, or I'll just click on the alarms list. And now you can already see all 3 sensors connected to D240, being flow, pressure, and temperature in orange, black, and red, are shown in one graph. I can pick if I want 1 minute, 5 minutes, 1 hour, or a day or a week's histogram. Only problem now is that since we're using a sinus curve for the flow, it's more or less obscuring our view here. I can still see the values by hovering with the mouse over it, but that's why I have switches up here. So I can turn individual graphs on and off, thus giving me not just the current state with colors of an object. So you see D240 has gone out of alarm now, but it also gives me the capability to trace historic data and go back. Again, it's also just another example of a third-party application that is seamlessly integrating into UDiTH to emphasize the flexibility of the whole system. So let's now also have a look at an early beta version of the AI integration directly within UDiTH. So what you see here is the UDiTH AI chat. In this case, let's start easily with select and fit D240. And obviously the first command will take a second, but as you see, it has actually selected my D240 with all its nozzles and fit my view to it. But let's do something maybe a bit more challenging by saying, okay, colorize all task equals piping light blue, task equals equipment dark blue, all valves yellow, and yeah, I think this will be sufficient for rather complex command. So the AI will iterate these steps and execute them separately. So now you see the valve query didn't find any objects with valve in the name. So I can say, okay, there is some ball valves in the model. Colorize them green. So even though the system might not be able to find something because the attributes are not really supporting this, you can still teach it how to recognize various objects. In this case, you see, now it has recognized my valves and colorized them green. So you can completely adapt this to chat with your asset, with your plant. The big advantage here is that the underlying prompt, this is actually intended to be a framework, so you can adapt the underlying prompt to give some initial descriptions to the system specific for a model that the end user does not have to enter. And also you can add tools. In this case, we have been using the GitHub Copilot to execute this, since most companies are using Copilot and this seems like a natural integration. But you could connect more or less to any AI system in the background, since no sensitive data is being exchanged, but there's a toolkit or tools that are running locally in the app in the background, and it's only using the AI to kind of assemble the correct commands here and to interact in natural language with the end user. So let's dive into the UDiTH portal. The UDiTH portal is the central distribution platform and the central landing page, not only to distribute your models on the cloud, but also in your internal networks with no internet connection, but high availability and permission management. Let's look into the details. So the UPV web services had some capabilities to distribute models, they had to be manually copied to the web services server, to the render servers. If you have multiple ones, you had to make sure that it's really the same file version and so on. So this has changed with UDiTH and the UDiTH portal. The central model repository is one central spot with model and version IDs to store your models. With the UDiTH browser, which is permission-based, users have access to the model to either open it locally, to download it for offline usage and check out a license, or to view it through browser-based viewing. And here again, the render servers are pulling the model from the central repository and enhanced with real load balancing. You're basically making the best of your infrastructure, no matter which channel the end user uses to access the UDiTH workspace. It all runs smoothly through the central model repository. When the model is actually provided, or we call it uploaded, even though it could be completely offline, to your central to your UDiTH portal, you can also predefine certain attributes to be indexed centrally, and this enables the central search. But let's look at the real deal. So what you see here is the default view of the UDiTH portal. First of all, you see three models because we have an auto logged in user that has permissions to view these models. I can now log in as a different user. So you see, I get a login screen. So in this case, we're using our Azure single sign-on, and suddenly I have the AI model that I used for the UDiTH AI presentation, which is available only if I have permission to view it. So let's look at the central model repository or central distribution. First of all, I can open the plans directly in the browser and have the full UDiTH features like I do on my local machine. But perhaps I don't have an internet connection or I want to view it locally. So in this case, I can select open locally, and I have to switch screens quickly. UDiTH will open up in a local instance and open the model in my local application on my Windows, iOS, or Android machine and load the model. But let me close this and switch back. Perhaps I want to work offline. So in this case, I can actually download an encrypted file, and again, my local UDiTH application will open. And the difference between the actual viewing locally and downloading is that I get to pick what I want to download. So in this case, I'll say drawings, documents, additional objects, the catalog of sketch items, and I can even check out my seed to work offline and add number of days or hours. In this case, I don't want to check out. I'll just say, okay, save. And my model will actually store locally, and I can work in my local application. And I can take my tablet, even without interconnection, out in the field and have everything I need to work on site. Okay, let's go back to the portal. So in this case, it has authorized if I'm allowed to log in. So this is the central access, but what about central search? Well, I can search for tags. So you see some models do have tags. So let me actually search for S3D. So it will give me only those models that contain S3D in the tags. So let's say I want to add a tag, say laser scan. So this will give me only one model containing S3D and laser scan models. Besides that, I can also search centrally for tags. So instead of just, item tags, not just model tags here. So let's look for my favorite D240. So instantly I get a result. Well, D240 is present in all of the models, but I can also include old versions. So for my full demo plan, you see I have a version ID 12 and a version ID 13 I can view here. In this case, let me go to the results for 3D. Well, let's exclude the old versions. So I can open the model itself here, or I can actually click directly on the matched element, which I'm going to do right now. So you see, not just opens the model, but it fits directly to the item that I was searching for. And if I now look for, let's say, T240, again, it will give me the results. Let's say open in browser. Now it recognized that I already have a session open, and it directly went to my open session. So if I had this tab, for example, on a separate screen, I can use this search and search my already open model as well. And this does not only work for 3D, it works with PNID as well. So let me switch here to PNID, and again, our item tag, open in browser, it recognizes my open tab, and it zooms and selects my T240. Now, let's put this side by side. Go back here and now type in D240. Same thing. Going to 3D, open in browser, going to PNID, open in browser, and it recognized also all side-by-side setup and went straight to our objects in both 3D and PNID. So, but besides that, and I'll leave the model open, UDiTH also has some additional administrative features. So in this case, in the browser, I have a group maintainer that allows me to check on display names, usernames, and groups, but also our central model repository setup where I can import files, import folders. I have my dashboard that shows not only like the web services of UPV did, my licenses that I used by browser-based viewing, it's actually showing me all my licenses used and available. So in this case, if it's Windows, Android, or iOS local instance, it will be shown used by others. Otherwise, it will be shown as used or preloaded. So in this case, you see me having the demo plant open. That's why I left it open. I can, as an administrator, kill the instance. And once I go back here, the end user gets the notification session terminated by administrator. And the session is gone from the dashboard. So settings, migrations, that's all easy going. You have your user settings, assigning or actually setting user groups, limiting access or allowing access completely by folder structure or by model. You have an overview over your licenses and expirations, and you can also kind of customize your UI, including the description, the contacts, and even down to displaying different logos and similar, and showing links. So all in all, the UDiTH portal, even though it kind of covers a similar area like the UPV web services did, UDiTH portal allows whole new steps, whole new approaches, and also version and model management through a centralized interface. Which brings us to the question, how are UDiTH models actually generated? Well, for model creation, usually a capture station is used. So the source data goes to the capture station that holds the UDiTH adapters or converters. Some of them may require third-party software and the UDiTH builder. So the source data is fed into the adapters. If the adapter does require a third-party software, it handles it directly with the according application and generates a normalized input file that is handed to the builder to create the UDiTH model. So how would this look like? The various adapters have various functions, and as you can see, some of them require, for example, the adapter for Smart Review will require Smart Review in some cases. The adapter for Navisworks will require Autodesk Navisworks Simulator Manage. The Smart PNID adapter will require Smart PNID and so on. But all in all, it generates three different types of normalized files. UPVC for 3D, UPVD for documents, and UPVP for PNIDs. In the builder, with the UDiTH builder plugins and the SDK, you can add additional data, attributes, and graphics from any external source, or for example, custom attributes, color files, link files, which then are merged and federated into the UDiTH model that can then be sent to the UDiTH portal for model distribution and making it available to all stakeholders. But let's actually look at a real example here. So I've prepared some UPVP files for PNIDs from Smart PNID and a mapping file between 3D and PNID. And let's create some documents together. So for this, I will open up the adapter for documents, which allows us to feed multiple different source formats. In this case, I picked Smart Plan 3D, activated, layout drawings. This looks good. And I'll just call my output file GA for general arrangement from Smart 3D, and then just run the conversion. It reminds me that it's using a Smart Sketch license, and for large number of files, it is recommended to check out the license for the process of conversion, but obviously it's not necessary. So the documents we want to add to the model are converted in no time, as you can see. 26 seconds. So, but we also want to have some 3D files. So in this case, I will be using the adapter for Smart Review. The adapter for Smart Review consumes view files and again converts them into UPVC files, as I mentioned, the 3D file, intermediate file format. So yeah, let's pick this demo plant, create in this folder. Yeah, this looks good. And basically in the background, it will read the data. So why are we normalizing files? Because the various inputs have different file formats, and we want to make sure that UDiTH Builder works with the same information base, giving it the option to actually map files correctly and to combine and federate a model regardless of the source. And as you can see, capturing has been done also in some 20 seconds. And the next step will be federating the data into one model. So for this, we will open up the UDiTH Builder. So after Builder is loaded, you can see our demo plant to PVC has already been set because I've converted it previously. But other than that, you can browse for data. You can also pick multiple PVC files and store them as UPVM files, which is a mapping file where you can also define the relation between the different models. But in this case, let's go to settings. So under general, we can pick aspects. Under tree, we can even define our hierarchy. I'll leave it at system path now. The attributes to in or exclude. And under advanced, this is where we actually want to go now. We will add our general arrangement drawing, and we will add our PNIDs. Confirm, and then click on generate output. Here we can choose also a default coloring file, the output folder, PNID to 3D mapping file. In this case, I'll pick this IntelliPID attribute mapping, and that's it. Now, all the intermediate files are federated into one model. The documents are prepared accordingly. The PNIDs and 3D objects are linked to each other, and all of that will probably take far less than a minute for this model that we picked. So generating a model is not only easy, as you see, but it's also fast, and it can be automated. So this means you can use batch files, scripting, or similar means to fully automate the creation process. So in this case, exporting has been finished. Open the output file. Yes. So here you can directly see the results of your model building. All 3D objects are included with all the attributes, as you can see, but also, for example, the PNIDs are included, interconnected, layout drawings, pretty much everything we put into the model in no time. So, all in all, I hope I was able to give you a good comprehensive overview over UDiTH and its full capabilities and the full UDiTH ecosystem that is modular by design and open by philosophy. I hope I was able to transport that. So all that's left for me to say now is thanks for watching, thanks for joining in. And in case you have any questions, feel free to reach out to us and to have some individual demo and presentation where we can also maybe go into some of the details, what challenges you are facing and how UDiTH can solve them for you. Thank you a lot and goodbye.